Welcome to the PH1105 e-lecture. In this very short video segment, we will talk about the phenomenon of beats. So, beats are heard when two tones of slightly different frequencies, FA and FB, are sounded together. So, you're supposed to look at the figure below. So, this is two sound waves with slightly different frequencies. And it turns out that you also start them off with different phases. So, one of them is a sine wave. The other one is a minus negative of a sine wave, and you can see, okay, what you can see is that because the frequency is slightly different, the period is slightly different. So after some times, the two waves become close to each other. You can see here that they're close to each other. But then after other times, they'll start to become different from each other again, and then become close to the displacement will become similar to each other again, and then so on and so forth. So when the waves are approximately in phase with each other, and you add them up according to the principle of superposition, you get very large wave displacement. And when the waves are out of phase with each other, then you get cancellation, and you get very close to zero amplitude. And therefore when you plot this superposition of two waves, different frequencies, you get a pattern that looks like this. Okay, so what is so special about a pattern that looks like this? Now, a pattern that looks like this, you can see that the frequency of the oscillation is actually the average of FA and FB. Okay, so let's say if FA is a C note and FB is a slightly off C note, then you will hear the average between the two, which is a C note that is off by a lesser amount. Okay, so you'll hear the C note. Okay, but at the same time, what do you hear? You hear periodic variations in the intensity. That means that you will hear soft and then loud, and soft and then loud, and soft and loud, and soft and loud. So the tone remains the same, but the sound intensity seems to change periodically with time, going from loud to soft to loud to soft, and this is what the beat is. This is the beat that is being produced. And the beat frequency, we can show mathematically, and I will show it later on, is the difference between the two frequencies FA and FB. So if FB is very close to FA, then this beat frequency is very slow, and we can hear this loud, soft, loud, soft, loud, soft phenomenon. If this frequency is higher, then what happens is that this envelope itself is a frequency that lies within the audible range, and then we will hear it as a different tone altogether. Okay, and that in that case, then what we have is that we can have some kind of I forgot the word for it. And when you play two notes of the same frequency together, they can either sound harmonious together or they can sound discordant. So that's a totally different theory altogether. It's not a theory of physics; it's a theory of music. So those of you who do music, you probably have learned what kind of what is the note that goes together with C to form a chord. Okay, so for now, this is the qualitative discussion. So I will follow up with a maths derivation.